All right, I'm going to solve this system of equations using matrix row reduction. I've got this system of equations transposed into this matrix. 1, negative 1, 1, 3. And I've done that for all those numbers. Now the goal of this is to turn it into something that looks like this. With this being my answer for x, this being my answer for y, and that being my answer for z, if I can get it to look like that. I need to go in this order specifically. First, second, third, fourth, fifth, sixth. I have 6 things to do in that order. Okay? So the first thing to do is to get this number here to turn into a 0. So row 2 is going to be traded for something. I could do this minus double that. I'm sorry, I could do this minus double that. Sorry about that. Or this minus double that. I want this to go to 0, so I'm going to take this number minus 2 of those numbers. 2 minus 2 is 0. The other stuff we'll worry about later. That gets my first 0. My second 0 is right here. So row 3 is going to be traded for this one minus 2 of those. This is one way to do it, not the only way. So I'm going to go do this. I didn't mess with the top row at all, so I'm going to copy it. All right. This is middle minus double top. Row 2 minus 2 row 1. However you want to think about it. That minus 2 of those. That minus 2 of those. It's going to be 3. And that number comes from 1 minus negative 2. That's that number. And that minus 2 of those. I'm sorry, I got to do this one. This minus 2 of those. That minus 2 of those. That's what I get. This one says bottom minus double middle. Row 3 minus 2 row 2. That minus 2 of those. That minus 2 of those. That minus 2 of those. And that's going to be negative 1 minus negative 6 is 5. That minus 2 of those. All right. Done, done. Got to do these two right now. So I'm going to get this one and this one gone. But I can't or don't use R1. Don't use the top, because if you do, it'll mess with those zeros. You can only use these two. So row 2. That plus that goes to 0. So row 2 plus row 3. Row 3 is going to be traded. So we're going to do 3 of these plus 1 of those. Didn't do anything to the top. Alright, middle plus bottom. 0 plus 0, 3 plus that plus that, that plus that. That's what I get. Now row 3. 3 bottom plus middle. 3 row 3 plus row 2. Triple that plus that, triple that plus that, triple that plus that, and triple that plus that. Now I'm going to turn this into a 1 because it'll be easier to deal with. This tells me that x, y, z, 2y is equal to 0, 10z is equal to 2. So I can't divide, but I can multiply by a half, which is exactly the same thing. And I got to divide by 10, which would be multiply by 1/10. So I'm going to do that. I didn't do anything to the top. Divide by half, times a half, times a half, times a half, times a tenth, times a tenth, times a tenth, times a tenth. And that's what I get. I divided all these by 2 essentially. I divided all these by 10 essentially. Now the last thing I need to do is mess with row 1. Back to my little schematic up here, I need these two gone. Okay, so if I take this one plus this one, that one goes away. So I'm going to do R1 plus R2. I didn't do anything to the bottom two rows, so I'm going to copy them. Alright, on the top. Top plus middle. That plus that, that plus that, that plus that. So 1, that plus that. Last thing to do is get rid of that one. Alright, so we're going to trade it for this minus this. So that's R1 minus R3. Alright. Didn't do anything. Didn't do anything. Top minus bottom. That minus that. That minus that. That minus that. That minus that. That's 15 over 5 minus 1 over 5. There's my matrix. I'm done. I got ones down the diagonal. What does this say? This says x equals 14 over 5, y equals 0, and z equals 1/5. We could write it coordinate notation like this. A system of equation with 3 lines. Those 3 lines intersect at this point in 3D space. If you get a chance today, help somebody out.